Hello everyone, my name is Likit Yadav and I'm a graduate student at Colorado State University. The topic that I'm going to discuss today is survey on model compression techniques, pruning for neural networks and resource constrained devices. So why do we need to prune neural networks and what are the advantages of it? We can see that in recent development of machine learning led to accurate image classification and then accurate object detection. So all this can be done by using CNN and DNN, and most accurate CNN and DNN models contains millions of transmit parameters, and then they have huge model size, and they are memory intensive, and computational complexities are involved, and the operating cost is as well as more. So and it is harder to deploy these kind of DNN models or huge DNN models or CNN models on resource constrained devices. And that is the reason why we are pruning neural networks. In this slide, we're going to talk about convolution neural networks pruning methods. So what is pruning? Pruning is nothing but the removal of redundant or unwanted parameters or neurons in the convolution neural network. So by doing this, we reduce the model size and then increase the efficiency of the model. And so there are two main classes for the in the pruning method, that is non-structured pruning and structured pruning. Structured pruning is nothing but it removes the structured CNN parts directly from the CNN, and in result it compresses the CNN. At the same time, it increases the speed of the CNN, and at the corresponding kernels in the next layer of the CNN also should be pruned, and it can be implemented. This method can be implemented in either during the training or after the training as well. And when it comes to non-structured pruning, weights can only be zeroized and then pruned architectural and then pruned so that it has architectural consistency. And then weight pruning requires special coordination, and then these are hard to satisfy. And the main problem with weight zeroing is incorrect weight pruning. uh, the convolution neural network pruning method second strategy is training strategy. In this strategy, there are three different types of strategy. One is hardware pruning strategy, software pruning strategy, and then redundancy pruning strategy. The hardware pruning strategy is applied sequentially with the training process, and to recover the network's accuracy in this process, we reconstruct the layers one by one and then fine tune it. And this is implemented only to the structured pruning. Hard pruning is implemented only for the structured pruning. And when it comes to soft pruning strategy, it's a non-structured weight pruning, and then the elements are element zero is used to replace with the unwanted weights or unnecessary weights. And then after convolution layer, the soft mask is used to train the filter kernel pruning model and categorized as the mask vector and element property. And then the third strategy is redundancy learning strategy. Over here in this method, we make the redundant parameter zero, and then this strategy is similar to the identical filters and same, and to trim the redundant one, and it is it is similar to identical in one cluster. And the soft pruning and then the redundant learning pruning are better compared to the hard pruning in terms of the performance, and the training time taken for the hard pruning is more compared to the soft pruning and then redundant pruning. And the third in this slide, we're going to talk about the third strategy, which is estimation criteria. Over here, this estimation criteria employs to guide the train process, which is training process. And then there are three types. One is important based criterion. Over here, the element matrices and tensors are redundant, can be redundant parameters in pruning, and that definitely have the standard information about it, and commonly applied for rapid computation. And so, and you can see that some drop in accuracy due to compression of high model high dimensional data. And when it comes to sparsity based criterion, over here it aims to prune the filters and then share the similar data. Let's say share the similar data, and then the sparser architecture with a few parameters, and it has a greater extraction and power functionality and ability to interpret high dimensional information and lowest output drop in the non-structured and structured pruning. Reconstruction based criteria. In this criteria, it focuses on especially on the output feature map and then key concepts of to mitigate the inability to restore and the best approximation model pre-trained. And the functionality, another one is functionality dependent pruning methods. Over here we can see that in the structure generates sparse a neural network, and one type is structure pruning method. Over here it generates a sparse neural network which cannot be structured in a continuous way or speed ups or using modern libraries and hardwares. In the scoring pruning methods, it differs in the amount of network to be pruned and pruning all desired weights in a single move at once. In the scheduling based pruning methods, it's up it's pruned on absolute values, based on absolute values, and then qualified coefficient for significance, and the contributions to the network activation and gradients is popular to rate parameters. Fine tuning, it is the most common to continue to train network before pruning using the qualified weights. And conclusion, comparatively, when pruning is employed, we can see that the model size is reduced, and then it increases the performance of the model without any hardware cost. And then there you can see that reduction in the operating cost, and then we can deploy these DNNs or CNNs on the resource constrained devices, since all of the computation is done on the uh, server side, and then it's deployed on the embedded systems. And due to this we can see the fast reduction in the power consumption, because the efficiency of the model is increased. And that's all, and these are the references. Thank you.